Okay, so this is one of my favorite things to do as far as calculus goes, integration by parts. Okay, first I need to show you a proof of where this comes from. You're not going to be held responsible for it, okay? But the theory behind math is part of what we have to do. Okay, so here's a proof of where this is coming from. Given f and g, and you don't have to copy this down. You could just pay attention if you want. Okay, if you're going to be a math major, you'll be doing a lot of it. A lot of this. Given f and g are two differentiable functions. Okay, then f of x times g of x prime is equal to the first times the derivative of the second, right? Plus the first derivative times the second, or the second times the first, whatever. So I'm going to integrate both sides of this with respect to x. Okay, integrate both sides with respect to x. Okay, so let's see what we get. We're going to integrate f of x times g of x prime dx, and then we're going to integrate f of x g prime of x dx plus the integral of f prime of x times g of x dx. Okay, the integral of a derivative is just the function, right? If you integrate a rate, you get the amount that you started with before you got the rate. So that means this, okay, is just f of x, g of x equals the integral of f of x times g prime of x plus the integral of f prime of x, g of x dx. Okay, so this is the integration parts by formula. Okay? So the integral of u dv, so if I want this integral right here, u dv equals the integral of, equals u times v minus the integral of v du. So the integral of u dv, this is like your u dv, equals uv minus the integral of v du. Okay? Alright. So that's a proof of integration by parts. But what you need to memorize is the integral of u dv equals uv minus the integral of v du. You'll get used to it as we go. Okay, kids. Continuing this on, you're going to have a product, okay? So here's my product. I don't have to use IBP. Don't use IBP. There's a hierarchy. I'm actually teaching these in the order of the hierarchy, okay? This is just a simple U sub. You know how to do this already, okay? I had to put that here because you're going to think, oh, you know, I need to do integration by parts, but the thing is, you don't have to do integration by parts in that problem. Here is an integration by parts problem. Okay, so this is just kidding. Integration by parts. You're going to have a product. The way you need to think of this is your u is going to equal the function whose derivative becomes simplified. Okay? U equals the simpler function. Okay? There is a thing called Liate or Lipet. So this tells you your hierarchy. So if you have to choose, you're going to make your u equal to a polynomial function over an exponential function. So that's why I made u equal to this polynomial function. dv. So u dv, well, dv is e to the x dx. Integrate these. V equals e to the x. Okay, lucky number 7. You're going to hear me saying this a lot. Lucky number 7. So the integral of u dv, right, which is x e to the x dx. Let me color code that a little better. So this integral is equal to u v. See where the uv comes in? Lucky number 7. X e to the x minus the integral of v du. So you get e to the x dx. So therefore we get x e to the x minus e to the x plus c. That's the antiderivative. Okay, that's example 1. Let's take a look at example 2. So I have the integral. Remember, you're going to have a product, but you're not going to be using any other technique that we've learned so far. X cosine x. Okay, Lipet. I prefer Lipet. A lot of people prefer Liate. It doesn't matter, okay? So we're going to stick with Lipet. So L is ln, I is inverse trig, P polynomial, E exponential, T trig. So trig is last. So your u is going to equal x, the polynomial function. du is dx. The cos x dx is the dv. So v equals the integral of this, which is sine x plus c, of course, but don't worry about that. Lucky number 7. So the integral of x cos x is equal to u times v. That's x sine x minus the integral of v du, which is sine x du. So the integral of sine x, negative, this is a negative, so this is just cos x, so it's x sine x plus c. That's the antiderivative. Okay, example 3. We have ln x. This is a famous type of problem. So here's the thing. Okay, you're going to make u equal to ln x. Lipet. You have to make u equal to something. U is equal to ln x. du is dx over x, right? dv is just dx. When you integrate these, v equals x. Okay, so lucky number 7. The integral of ln x dx is equal to u times v. The order doesn't matter, commutative property. Minus the integral of v du. Well, look at what happens, kids. V du, those cancel. So you just get x ln x minus the integral of dx, which is x ln x minus x plus c. Most people memorize this one. Okay, you know that I'm honest with you and I'm very down to earth. Do I memorize this one? Only by default, kids. I memorize it because I've seen it enough. Okay, but in the beginning when I taught calculus, did I memorize this? No. So I'm not saying you have to memorize it. I'm not trying to intimidate you. I'm just saying that you can certainly memorize it if you wish. Here we go. The integral of arc sine dx. So Lipet, right? So I'm going to have u equal arc sine. Yes, you can write it either way, guys. Du, as you know, is 1 over the square root, 1 minus x squared dx. So now dv is equal to dx. So v, when you integrate this, is just x. Okay, lucky number 7. So I get u times v. Well, u times v is the same as v times u, so I get x arc sine x. U times v. Okay. Minus the integral of v du. Well, v is x. Du is this hot mess here. Okay, hold on. Not proud of how this hot mess looks. Looks nasty. Anyway, so now I have to integrate this. So what's going to happen is sometimes you're going to have to use other techniques to then integrate that. And this is why we learn these things in a certain order, kids. So I'm going to do a u sub. Let u equal 1 minus x squared du negative 2x dx negative 1/2 du equals x dx. Okay, so I still have x arc sine x. That just hangs around. Now, for this new integral, I have negative 1/2. But keep in mind, look, this is minus. So minus a negative is just going to be plus 1/2 the integral of du over square root of u. Okay, depending how smart you are at these things, you can say to yourself, what function has 1 over 2 square root of u as its derivative, and that's square root of x, right? You could also do it slower. You could make this 1/2 the integral of u to the negative 1/2 du, yada yada. You got to pick what you're comfortable with. So my final answer is x arc sine x. I'm going to put my u back in. Plus, it's going to be just, okay, u to the 1/2 like I told you. But u to the 1/2, my u is 1 minus x squared. Okay, guys, that's your entire answer. Okay. So continue with the next problem. This is example 5. The integral of x, okay, sine x squared dx. All right, you don't have to use IBP here. This is just a u sub. I just want to make sure you're still awake and you're paying attention as you're copying this down, that you understand. U sub comes first. U sub gets preferential treatment. Okay, here we go. How about this? Remember, Lipet. So what's u going to equal? X or sine x? The polynomial function, right? So u is x, du is dx, dv is sine x dx. Integrate, v equals negative cosine x. Lucky number 7. Okay. This lucky number 7, by the way, comes from Ask Mr. Calculus. I just had to meet the guy in person, considering how much effort he puts into that website. And to tell you the truth, it wasn't disappointing. He's one of the nicest people I've ever met in this field, okay? So this integral is equal to uv, which is negative x cos x, minus the integral of v du. But look, this is already negative, so minus negative is plus. Cosine x dx, well, that integral sine x. So there you have it. It's a typical integration by parts question. Example 7, the integral of x e to the negative 3x dx. Okay, LIPET. This is not a u sub because the derivative of negative 3x is negative 3, but I have an x in the problem. So this has to be LIPET. So I have u equaling x, right? Du dx. The integral of e to the negative 3x dx, because this is dv. V is equal to negative 1/3 e to the negative 3x. Okay, so my formula, lucky number 7, my formula is u times v, so that's negative 1/3. X e to the negative 3x minus the integral of v du. But this is negative again, so it's going to end up being plus 1/3 e to the negative 3x dx. So I get negative 1/3 x e to the negative 3x. Now here's where you need to be careful. When you integrate e to the negative 3x, it's e to the negative 3x divided by negative 3, which makes this a negative 1/9, kids, plus c. So you have to think ahead a lot of times. Okay, example 8. So for example 8, I have the integral of x squared e to the x. Now I'm going to do this the long way. You don't need to copy this. I'm showing you this. I just want you to watch this part. Then I'm going to show you a shortcut. So I have u equals x squared. Du is 2x dx. dv, e to the x dx. Integrate, v is e to the x. Lucky number 7. So this answer would be x squared e to the x minus the integral of 2x e to the x dx. So now I start over again. I have u equals x, dv, dx. dv equals e to the x dx. So v equals e to the x. So it's uv minus v du. Lucky number 7. So I have x squared e to the x minus the quantity. I'll put the 2 out front. Minus 2 times the quantity. U times v minus the integral of v du. So that gives me x squared e to the x minus 2. X e to the x, and the integral of negative e to the x is negative e to the x plus c. So I get x squared e to the x minus 2x e to the x plus 2e to the x plus c. Oh, that was tedious. Okay? That was like a little mini marathon. So there's an easier way. There's something called the tabular method. You're going to use this when you have a polynomial function and a transcendental function. Transcendental means e or trig, okay? So instead, I'm going to make a table. I'm going to say, okay, I have the sine, I have my u, I have my dv. So my sine is just going to alternate. But my u starts off as x squared, my dv is e to the x. In this middle column, you just get the derivative, 2x to 0. You stop at 0. In the right column, just get the integral. Now you're going to take turns with the signs, plus, minus, plus, minus. You're going to go diagonal. So you're going to go like this, like this, like this. Okay? So your final answer is going to be x squared e to the x minus 2x e to the x plus 2e to the x. Look how much simpler that was than what we did up here. So the tabular method is a legit method. You are allowed to use it, so feel free to do that. Okay, example 9. X. So I have the integral of x squared cos 2x dx. I'm going to use the tabular method. So I'm going to start, I'm going to have my sine, then I'm going to have my u and my dv. So I start off, u is x squared, that's 2x, that's 2, that's 0, stop. My dv is cos 2x, so I have to get the antiderivative. What has a derivative of cos 2x? That would be 1/2 sine 2x, because we compensate for the rate. What has a derivative of 1/2 sine 2x? That would be negative 1/2 times 1/2 cosine 2x, which is negative 1/4 cosine 2x. What has a derivative of negative 1/4 cosine 2x? That would be negative 1/4 times 1/2 sine 2x, which would be negative 1/8 sine 2x. Okay, alternate the signs here. Plus, minus, plus, minus. You're going to go diagonal. So you're going to go like this, like this, like this. Okay, so the final answer is going to be 1/2 x squared sine 2x plus, because it's minus and negative, okay, one-fourth, okay, times 2x times cos 2x minus 1/8 times 2 times sine 2x plus c. Okay, clean this up. I get 1/2 x squared sine 2x plus 1/2 x, or just x over 2, right? Cosine 2x minus 1/4 sine 2x plus c. Okay, that's example 9. So this tabular method only works when u is a polynomial function. Okay, in this class we do things that are beyond the scope of the AP exam. So the next thing I'm going to be doing is called the wraparound IBP. Okay, we do this every year. It's like you have to make it through this to be in the class, right? It's one of those things. It's going to just turn into an algebra problem. It's going to seem like it's super sophisticated, but it's really not. So I'm going to let u equal e to the x. Du is e to the x dx. My dv is sine x, because I'm doing LIPET, right? So exponential has to come before trig. Dx, when I integrate this, I get v equals negative cos x. Okay, lucky number 7, kids. So I get u times v, which is negative e to the x cosine x. So remember, the formula is the integral of u dv equals uv minus the integral of v du. So I got my uv minus the integral. Now it's minus and negative, so that's going to be plus the integral of e to the x cos x dx. So now I start all over. U is e to the x, du, e to the x dx, dv, cos x dx. That means v is sine x. Lucky number 7 again. So I get, hold on, I'm just bringing this down. But over here, I get u times v. So that's going to be e to the x sine x minus the integral of v du, which is going to be the integral of e to the x sine x dx. Oh, wow. What? Look at this, guys. Didn't this integral start off with this? All right. So let's think about it. I have the integral of e to the x sine x dx equaling negative e to the x cos x plus e sine x minus the integral of e to the x sine x dx. So these are a match, right? This matches this. Can't I just bring them together? So can't I just add this to both sides of the equation, just like the letter A, just like the letter X, whatever? I can just add this. So isn't this just double what I had? So 2 times the integral of e to the x sine x dx equals this hot mess. And then can't we just divide by 2? So it's all that divided by 2 plus c. All right, that concludes this video. I hope this was a good introduction to integration by parts. I look forward to seeing you in class.